I'm going to talk about 7.4, which is definite integrals. There will be no word problems on the test. If you want to look at some examples of word problems, though, you can look in Canvas. I have some extra examples that have some word problems in there. So the biggest difference here is that we're going to be taking an interval to look at the antiderivative. So there will no longer be a c involved because we're looking at a specific interval, so that constant will end up going away. So some properties, again, just as where it's telling you if you're just looking from A to A, which is number 1, there is no area under that curve, so that's what we're finding, so you would have 0 as the answer. If you have a K, just as we've done before, we can pull that constant on front, which is number 2. Number 3, if we have a plus or minus, we can look at each piece separately. Again, that's not a new idea. Number 4, it tells you that you can actually split the interval up because, again, area over the whole piece would still be the area of 2 smaller pieces added together. And number 5 is telling you that if you flip the interval, because of the way we actually find it, if you look back up at the top, we actually subtract the 2 values. So if you flip the interval that you're looking over, it'll make it a negative answer. So I have the summary right there. No C's. Area under the curve is what we're actually finding. If we were doing word problems, we would be finding that additional revenue, cost, profit between your interval. So instead of just saying we want the total cost for up to 25 items, we would be finding the cost from 20 items to 25 items. So it would be giving me that interval piece. So the first one we have here, just kind of want to give you a picture, an idea of what we're dealing with. So we're taking the interval of a constant, and remember when we're actually finding the antiderivative of a constant, we just actually, the rule says we put an x in the end, and we would normally put a plus c because we don't know it. But I'm now looking over the interval from 4 to 2. So I am now going to plug in for x at 4, so that'd be 3 times 4. And over here it'd be 3 times 2. Be careful, make sure you know you're subtracting. This would be 12 minus 6, which gives me 6. I just want to give you a visual over here. So if we had a constant function, that would be 3. And I'm wanting to look at it between 2 and 4, and that's the area of the curve. We could actually just visually look at this. That means that my height is 3 everywhere. Okay? This distance here, my width, would be 2. So 3 times 2 would be 6, which is the area under the curve. So it just kind of gives you a visual idea of what we have, what we're doing for that piece. So please remember on the test, if it is an indefinite integral, which is 7172, you have to have a plus c unless they give you more information to find it. Starting in 7.4, we're dealing with definite integrals, which have intervals on those pieces, so you're going to have to be careful. So number 1 is a really easy one to fall into the trap because you see the square root value, but this is actually a constant. So same idea as what we did before. It's actually square root of 2 times x because there's no x involved there. And we're evaluating from 1 to negative 4. So again, we're going to subtract after we plug in. So that's going to be square root of 2 times 1. It's going to be square root of 2 times the negative 4. So get square root of 2. This negative and negative will cancel. 4 square root of 2. Remember, you can always put a 1 in front to help you, so I now end up with 5 radical 2 as my answer. Going to number 2, we have 4z plus 3. So remember, we're going to use the power rule here. We add 1 to the exponent and divide by the new exponent. So I'm going to have 4z squared divided by 2 plus 3z. We would normally put a plus c, but we know we're not going to need it since we're evaluating from negative 2. So we have 2z squared plus 3z. And we're going to plug in our 2 values. 2 times 2 squared plus 3 times 2. This is going to be 2 times negative 2 squared plus 3 times a negative 2. So in here, I'm going to get 8 plus 6, which is 14. Over here, I'm going to get 2 times 4 again, which is 8, plus a negative 6. So I get a 2. 14 minus 2 gives me 12. That is my answer. We did number 3 in class, so I just was reminding you over here that these are the 3 forms that we're going to use. So you're looking to see that piece. Since there's plus and minuses between these, we're going to be able to split it up and take the integral of each piece. So again, we're using the power rule. We add 1 to the exponent and divide by the new exponent. That's how I get a negative x cubed over 3. Negative 3x squared over 2 plus 5x. We evaluate at 3 and negative 2. And again, you want to keep those fractions as an answer because only decimals that are exact are okay unless they specify that. So we get a negative 15 halves minus a negative 40 thirds. Again, you can use your calculator at this point to simplify this. It's okay to use your calculator in here, but you need to at least show me what each one is equal to. So like minimum would be this line here in green, negative 15 halves minus a negative 40 thirds. I really recommend you showing me this first step because if you make a mistake typing in your calculator, I don't know that if you're not showing me that work. So all I did on here was just kind of remind you of how you would type it into your calculator. So if you want to look at this a little longer, then just pause it and you can look at that format. So we're going to look at number 4, and remember again, at any time you can pause this if you need to see this. So we have, again, 3 options. Power rule, we have our natural log rule, and our E. And we can see here that we're going to have to use substitution to actually do this because we don't have an x to a piece. We have actually a full piece underneath here. So we're going to start off and let u equal 2r minus 2. Take the derivative of that, du over dr equals 2, because remember the constant would go away. Multiply by the dr, and now we're going to look at what we have in the problem. All I have is a dr, so I need to multiply both sides of this by a half to get it in the correct form. So I get a half du equals dr. Now I can substitute this for the dr and this for what's underneath the radical. So I'm going to rewrite it, and I want you to stop. What we're going to do when we do substitution, there's 2 ways to do this. We're going to do it the way we're going to do an indefinite integral first until we plug it back in, and then we'll evaluate at the interval. You can actually do it a little different way, but we're going to do it using indefinite integrals first. So I'm going to rewrite it so I can use the power rule. Now I'm going to substitute in. So I get u to the half power, and I get 1/2 dr. Put that half in front. Sorry, that should be a du. We're changing that piece. So now I can take the indefinite integral. So remember, we have a half, and we're going to add 1 to the exponent and divide by the new exponent. And we would have a plus c. So I'm going to flip that fraction. That's going to give me a 1/3 u to the 3/2 plus c. And now I'm going to resubstitute in. So I have a 1/3 2r minus 2 to the 3/2 plus c. That's my indefinite integral. So I did this piece here with the substitution, but I found actually again what the antiderivative is. So now I'm going to evaluate. Now I'm going to evaluate at the interval 9 to 3. So again, I'm going to put my 2 parentheses, plug in. So when I plug in here, I'm going to get 1/3. This is going to be 18 minus 2 to the 3/2. 2 times 9 is 18. Over here, I'm going to get 1/3, 6 minus 2 to the 3/2. The c would go away because notice I'd put a plus c and a plus c, so they would cancel out. Again, you can let your calculator simplify this. Just be careful. you should get 64 over 3 minus 8 over 3, which gives you 56 over 3 for the area under the curve. Again, there's more than one method to use substitution. I find it easier for y'all to do the substitution with the indefinite integral, as we did in 7.2, and then stop and evaluate it. Looking at number 5, we have a negative in front, so again, be careful. That negative actually distributes to both of them. I can use the power rule directly here. I do not have to do substitution because the x is directly related to that. But again, I'm going to rewrite this and put the negative with each piece so that I'm careful with that negative. So I'm going to evaluate using the power rule again. Add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent. We're now going to, again, simplify before we evaluate. So I'm going to flip that fraction. So I have a negative 3 times 2/5. And here I would just flip it. So I'm going to simplify this, my last step before I plug in. So that's going to give me a negative 6/5 x to the 5/2 minus 2/3 x to the 3/2. And I'm evaluating from 4 to 0. When I plug in, I have a negative 6/5 4 to the 5/2 minus 2/3 4 to the 3/2. Notice I put parentheses there so I'm really clear on what's being raised to the power. If I plug in 0 into this, it's going to be 0 and minus 0. So I get a 0 there. So I'm only really concerned with this first part. And again, you can type this in your calculator and simplify. You should actually get 32 if you were to do this by hand, and this would give you an 8. But I'm going to go ahead and just, again, write down what you would have gotten if you actually simplified each piece separately. You can use your calculator to simplify. That's fine. But I expect to see, again, you actually, what did you get, which is here in purple, at least one line in red where it's showing me that you're actually plugging in, and then your answer. Some of you will do the steps in between. It's okay for you to use your calculator, but please, please be careful. If you don't show me the work, I can't give you partial credit for making a mistake in your calculator if I don't know what you did. So we have 2 more, and these are actually in Canvas as well. So I can use the power rule on number 6. First going to rewrite it. And I want you to be careful here. This is r to the first, and this is r to the 1/2. So that actually gives me r to the 3/2 power. I'm going to say that again. You have r to the first, and you have r to the 1/2 power. You would add your exponents, which gives you the 3/2. So now I can use my power rule. Add 1 to the exponent, divide by that exponent, add 1 to the exponent, divide by the new exponent. I'm going to flip those to, again, make them so that I can deal with it. So this is going to end up being 2/3 times 4, which is going to give me 8/3 r to the 3/2. Here I'm going to get 3 times 2/5, and that's going to give me a minus 6/5 r to the 5/2. Now I'm going to evaluate for each piece. So 8/3, 9 to the 3/2 minus 6/5, 9 to the 5/2. Show me that step. So I know that what you're typing in your calculator is what you should be doing. Here I'd have 8/3, 4 to the 3/2 minus 6/5, 4 to the 5/2. I personally show each step out, so I actually calculate the first parentheses, which is a negative 1,098 divided by 5, and the second one would be a negative 256 over 15. Be careful because these negatives will end up canceling, But when you again let your calculator simplify that for you, you should get a negative 3038 over 15 as your answer. You can get a negative area. That just tells you actually, if you were to draw the graph, it's below the axis. That's what it's telling you. So last one, number 7. Looking at this problem, we're going to have to use substitution. Okay. So you see a denominator, and that might be your first gut instinct, and you may try it, but that's not going to work. So we are going to try using the power rule. Let u equal 2p plus 1. So take our derivative, which gives me 2. So I get du equals 2 times dp. So I'm going to come back over here and rewrite what I have. And remember, I'm going to use an indefinite integral first. So I have 2p plus 1 to the negative 2, and I have a negative 3 dp. This is the first part. Now I've got to get it to match this part that I have left. So if I go over here, it looks a little tricky. Okay? I have a 2 there, so I need to get rid of that 2. So I'm going to do this in 2 steps. I'm going to multiply both sides by 1/2. And then looking at this, I would need to multiply both sides by a negative 3 to get that value that I have. So I have a negative 3/2 du equals a negative 3 dp. That's my substitution. It's a little bit more complicated than we're used to. So this is what matches our blue. This is what matches our yellow. So I'm going to substitute u to the negative 2, and I have a negative 3/2 dp. So I'm going to pull that piece out in front. Now I can integrate. Add 1 to the exponent. Divide by that new exponent. Remember your plus c. So I will get 3/2 u to the negative 1 plus c. I'm going to now plug back in for u. So I get 3/2, and again, this would be now in the denominator, right? Because it's a negative exponent. So 2p plus 1. It would be 2p plus 1 to the first power, so I'm not going to put that plus c. So this is for my substitution method to integrate. So now I've got to evaluate for my interval from 1 to 4. So remember, we're going to put our parentheses and plug in. So I have 2 plus 1. If I want to plug in, sorry, it's not going to be 2 plus 1. 2 times 4, which is 8 plus 1. My second one over here will be 2 plus 1, because that's plugging in the 1. You can simplify that piece out. You will get 3/18 minus 3/6, which again you can do by hand, but you can also let your calculator simplify that for you, and you should get a negative 1/3. When you need to use substitution, please again use an indefinite integral because it'll make it easier and less confusing, and then evaluate once you plug back in for that piece.